All right, what I'm going to do here is 3 examples from Chapter 8, which basically covers the most important parts of Chapter 8. When there's a claim about a mean, that means that we're going to be using the t as the test statistic, and the critical values will be in Table A3. So first of all, find the claim. So with this one, the class claimed the average, so that means mu. At least means bigger than or equal to 80. Next, what I do is write down the sample information. So n is equal to 39 students. The mean x bar is 76.1 and s is 14.2. Then write down the claim. The mean is at least 80. Then the alternate hypothesis. The main rule for the alternate hypothesis is it cannot have an equals. Since the claim has an equals, the alternate hypothesis in this case has to be the opposite. And the job of the alternate hypothesis is to tell us how many tails there are. Since this little inequality is pointing to the left, that means this one's left tail. Next up, H sub O always has equals no matter what the other two say. Okay, the next thing to do is draw the t distribution, which looks like the normal distribution. This one is left-tailed, and over here I said to use 98% confidence, which means this side is 0.02 and this side is 98. Now we'll look up the critical value. So that's table A3. And for A3, we need the degrees of freedom, which is n minus 1, so it's 38. So we need 0.02 and 1 tail, and degrees of freedom is 38. So now let me go over to the table. So we use this part that says 1 tail, and then they don't have 0.02, so use what's closest, 0.025. So use the middle column, and then degrees of freedom is 38. So that's going to be this one right here, 2024. Since it's on the left, it's going to be negative 2024 with a little decimal point in there. Then for the test statistic, you could use the formula if you want, but I would use the calculator, and that's called the t-test. Now I need to go over to the calculator. So this is like a T83 or a T84. When I go to stat and then tests, then I'm looking at number 2, the t-test. And on this version it draws the picture, but that's not really important. So here I entered the information. So the number from the claim is 80. You can see I typed this one in before. Let me double check all the numbers right. X bar equals 76.2. Standard deviation is 14.2. But N is 39 students. And then enter. And it says negative 1.671 if I go to 3 decimal places. Okay, then go back to our work. So it's negative 1.671. And then comparing a 1.671 to the critical value, it does not make it past the critical value. It would land to the left, but it wouldn't quite make it. So the only way to prove something with hypothesis testing is if it lands over here past the critical value. Otherwise, we did not prove anything. So then, officially what you say is, fail to reject H sub O. In other words, if you look back here at H sub O, it said it's equal to 80. And by saying fail to reject, that means we do not know one way or the other. We cannot tell. So finally, we did not prove anything here. So again, if it was to go past the critical value, then you could say, okay, their claim is true or their claim is false. But if it doesn't go past the critical value, we just didn't prove anything one way or the other. All right, on to the second example, and that is about proportions. So when it's about proportions, then we use Z as the test statistic, and then the critical values are in table A2. All right, next, find the claim. So the claim is that the majority, and this means that it's over 50%. So in other words, the proportion is over 0.50. And then for the sample data, N is equal to 55. And X, successes, is equal to 32 female. And then if you divide those two, that's called p hat, 32 divided by 55. Let me move over to the calculator. 32 divided by 55 is, if I round that to 3 decimals, it's 0.582. So 0.582. So that definitely is over 50%, but is having 55 people really enough to prove it in general? That's what we're doing here. So the claim is that the proportion is over 50%. Like I said, the main rule with H sub 1 or the alternate hypothesis is that it cannot have an equals. Since this claim does not have an equals, that means H1 is the same. And then since that arrow is pointing to the right, it means it's a right tail. And H sub O ignores what everybody else is doing and always says equals. And then draw the picture. It's a right-tailed test, so the critical value will be over here. And in the claim, I didn't say what to use for the level of confidence. Whenever that's left out, use 95% as a default. So this side would be 95%, this side would be 5%, and then use table A2. And for table A2, you do not need any degrees of freedom. All you need to know is this number right here, 0.95. So let's go to the table and go over to, there it is, the positive z-scores. And then you search for 0.95. There's actually a tie right here between these two. And if you follow the little arrow, it says if you were looking for 0.95, then the critical value to use is 1.645. So this is 1.645. And now for the test statistic. And for that, we can also use the calculator. It's called 1 proportion z-test. And for that, I need to know this number, 55, the 32, and also the number that's in the claim. So now I'll just skip on over to the calculator. Go to Stat, Tests, and then it's going to be number 5, 1 proportion z-test. So the number in the claim is 0.50. X is equal to 32. And N is equal to 55. Enter. And so it's a 1.214, rounding to 3 decimals. So Z equals 1.214. And I just want to point out, if you look right below that, it says the p-value is 0.2249. So that's essentially saying if you make a conclusion, there's about a 23% chance of being wrong. And that chance is so high, we are not going to make a conclusion. So it was Z equals 1.214. And again, you can only prove something if it lands over here, past the critical value. But a 1.2, it would land to the right, but it would not make it past 1.645. So this is another one where we failed to reject H sub O. And we did not prove anything, or another way to say it is we can't make a conclusion. All right, then on to the last one. And the last one is about standard deviation. So if it's about standard deviation, then we're going to be using chi-squared as the test statistic, and table A4 is where the critical values are. So for this one, the claim is that the standard deviation, so that's sigma, is over 15. And then I need the sample information. That's based on 33 students. And the S is 17.9. So once again, write down the claim. This one is the standard deviation is over 15. H1 cannot have an equals. Since this one doesn't have an equals, it stays the same. And that's pointing to the right, so that's a right-tailed test. And like always, H sub O says equals. Okay, then draw the picture. And with the chi-squared distribution, it cannot be negative, so it starts at 0. And then it's skewed like this. Since this one's right tail, I would have this. And again, I didn't say what to use for level of confidence, so use 0.95. And that means that the right tail is 0.05. And we're going to use table A4. And that means we need degrees of freedom, which is n minus 1, so that's 32. Then look up the critical value in table A4. So here's table A4. This is the one that's split down the middle, and we need chi-squared right, so we're using the right side. And on the right side of our picture, there was a 0.05. Then go down to degrees of freedom of 32. And they don't have a 32. The closest they have is 30, so we'll use 30. Let me make sure I have the right column. So that's this column. So it's going to be this number right here is the critical value. 43.773. 43.773. And then for the test statistic, this one is not in the calculator. There's very, very few that aren't in the calculator. This is one of them. But the good news is it's a very small, easy formula. You just take degrees of freedom, then the sample standard deviation S, square it, the number from the claim, and square it. So that would be degrees of freedom is 32. And then S is 17.9, square it. The number from the claim is 15, and square it. So then, let me use the calculator. Just the regular home screen. So degrees of freedom was 32, and then 17.9 gets squared, divided by 15 gets squared. And that's a 45.569. 45.569. And this one actually makes it into the critical region because a 45 would land to the right of 43.773. All right, good. We finally proved something. So the next thing to do is you say reject H sub O. which is basically saying this equal sign is wrong. It's not equal to 15. Then the original claim said that it was going to be over 15. That was an ugly check mark. Over 15. And sure enough, the sample standard deviation was over. Also, when this lands to the right, over here, that means over. If it was to land to the left, that means under. So since it landed to the right, that means over. And also this, sure enough, is bigger than 15. So the claim is true. And that is a quick summary of Chapter 8. And the good news is once you get this done, Chapter 9 is just like it, except instead of one group, you'll have two groups, but the setup and the work will be the same.